Hi, my name is Matt Johnston. I'm CTO at Polyseam, and today I'm going to talk about open source infrastructure deployment. Then I'll demo the tool we built, CNDI. There's a growing list of services that we depend on as we build and grow our organizations. We rely on databases like Postgres and MongoDB, orchestration tools like Airflow, streaming and event services like Kafka, and many more. We expect these services to be fast, reliable, and highly available. When we decide to implement a new service like Airflow, we're faced with an important choice right away. Should I build or should I buy? This is actually a trick question. Self-hosting is free, and as of quite recently, it doesn't really require any building either. In the past, paying for a platform as a service was sensible because it was often easier, more performant, and more reliable than running that same service yourself. But that's not true anymore. So what changed? We now have a universal operating system for the cloud, which makes it trivial to deploy production distributed systems. It's called Kubernetes, but bear with me, please don't leave. At this point in your career, maybe you've heard people say, you don't need Kubernetes. Or maybe you've looked into it and quickly learned it's really quite complicated. Trust me, we know that Kubernetes is often too big of a burden to thrust onto developers, but that's because Kubernetes was never meant to be the final abstraction. Every cloud is built on top of Kubernetes, and our team at Polyseam has done the same thing. We provide an opinionated framework for provisioning and maintaining Kubernetes clusters and applications. It's called CNDI. The tool chain makes the complicated decisions for you, while giving you the flexibility to override them as needed. CNDI brings together the infrastructure as code tool Terraform and the Kubernetes continuous delivery tool Argo CD, and it provides you with the workflow you know and love as a modern developer. Because our framework has integrated these tools, we're able to provide templates that include the infrastructure and the application to help you ship, maintain, and grow your self-hosted service on your terms. We provide the tools to help you deploy any service you need and provide a simple mechanism for improving it over time. You only need to specify the attributes you want to change. Otherwise, you can just rely on the stable, performant, and battle-tested defaults we created for you in our templates. And because Kubernetes can run anywhere, we provide a simple way to install our templates in every environment. If you've created an application yourself, or if you have expertise in deploying a given service, you can create your own templates with our JSON-based configuration and share those files online. Once you have a template, CNDI makes self-service deployments repeatable while following the latest cloud-native best practices, including GitOps. Let's take a look at how all this comes together using Airflow as an example. Let's quickly look at the steps we'll be going through in this demo. First, we'll install CNDI on our machine. Step 2 is to create a Git repo for our CNDI cluster. Step 3 is to call CNDI init to initialize our project files. Step 4 is to make our secret values available in GitHub Actions. Step 5 will be to push our project files to GitHub, which will trigger some automation. And the last step, step 6, will be to update our DNS records, and our Airflow service should be good to go. Let's jump right into step 1, installing the CNDI CLI. Installing CNDI is very simple. Just type cndi.run in the URL bar. You'll end up here at the GitHub repo polyseam/CNDI. Just want to scroll down here. This is where the project is maintained, and it's also where you can find the README. And it's this line from the README that we'll use to install CNDI. Paste that into my terminal. There we are. And we can run cndi-help to prove that that worked correctly. Sweet. You can see a list of commands available in this CNDI CLI. The one we'll be working with next is CNDI init, but first we should create a repository for our CNDI cluster. To create our repository for our cluster, we're going to use the GitHub CLI. First, I'll just go to where I like to clone my repos here, and we'll do GitHub repo create, Polyseam/my Airflow, and we'll make that a private repo, and we'd like to clone it down after we create it. Cool. So now we can see the end of that cluster repository now. Now that we have a repo here, we can call CNDI init, and we'll do that in interactive mode. It's asking for a name of our CNDI project. It's going to use the folder name we're in by default, so that's my Airflow. We're going to select the EC2 Airflow template, and now this template is going to prompt us for a bunch of values here, and they'll all be relevant to deploying our Airflow cluster, starting with the credentials to access the cluster repo itself. We'll provide the URL to the repo we just created here. And we'll use the default AWS region. I'll get my access key ID from the AWS console, access key secret from the same place. And now it is looking for the repo where Airflow should find our DAGs. If you've never worked with Airflow before, DAGs are Python files that it orchestrates. And I have my DAGs in a private repo in my personal GitHub under the repo name demo dagbag. And I'll give it my GitHub username as well. And GitHub access token. Now we get to choose what domain name we'd like Argo CD and Airflow to be accessible on. I'm going to put argocd.cndi.link and airflow.cndi.link. Next, it wants an email address that it can use to attach to our TLS certificates. And I'll use my Polyseam email for that. Default username for Postgres, default password for Postgres, default database name. Looks good to me. Awesome. So CNDI has just created a bunch of files for us, including Kubernetes manifests and Terraform files. We'll open those up in the editor and take a look. So CNDI is designed to take two files as inputs for your cluster. CNDI-config, this is the central file to your CNDI deployment. It describes what how many nodes your cluster should have, where those nodes should be deployed, what kind of VM should they be, how much disk should they have. We have the cluster manifest section where we can put arbitrary Kubernetes resources. And then down at the bottom, we have the application section where we're installing the Airflow Helm chart as well as the cloud native Postgres Helm chart, because Airflow will use this CNPG database as its metadata store. So everything you need to know about your cluster is probably in this file. We have also given you a README that's specific to the template that we chose. And we can modify this file however we see fit. And then to persist those changes, we can call a command called CNDI overwrite. But we always just type it as CNDI OW. That will take the source files from your JSON, the source objects from your JSON, as well as the secrets you have in your .env file. It will combine those together and put the product in the CNDI folder of your cluster repository. So the cluster manifests section has a bunch of arbitrary Kubernetes manifests. It has two applications, one for Postgres, one for Airflow. And then we also have the Terraform folder, which has all of the cloud resources that we're going to be requesting from AWS. So from that, we got a great foundation here. The next step, step 4, is to take the secret values from our .env file and add them to the GitHub Actions runtime. We don't want to take any of these values and put them in the source code itself, because then they would be unencrypted and kind of visible within GitHub, and that's no good. So instead, we'll use this GitHub CLI command called secret set, and it will take these variables from the .env file and it will add them to the GitHub Actions secrets. Here I'm just going to call GitHub secret set to set the environment variables in the GitHub Actions runtime. And sometimes this takes just a couple tries here. There's a bug on the GitHub end, should be fixed soon. Anyway, From here, now that all those values have been set, we can git add dot and do a quick git status, and we can see that these are all the files that CNDI has created for us, and that all looks good to me. So we're going to commit, and just an arbitrary commit message here. Now when I run git push, we expect that that's going to trigger some automation on the GitHub side. Here we are. We can click through to the repository, and with that, just give it a quick refresh. There we go. Our job has kicked off. This goes through installing the CNDI CLI in GitHub Actions. There it goes. And then it's going to call a command called CNDI run. And it's going to call CNDI run with the context that all the .env variables here, all our environment variables, are going to be present. So we see there we're going to get 23 resources from AWS, 23 brand new resources. 3 of them are virtual machines, and then there's things like load balancers and VPCs and security groups and all of that as well. So we could expect this to take about 10 minutes. When all is said and done, we'll see a link to our load balancer here in the output, as well as a link to our resource group. And I'll show those once this finishes. So as expected, that just took a couple minutes here, and we have 2 outputs. We have the domain name for our load balancer, and we have a link to the resource groups as well. And here we can see that the My Airflow resource group has a bunch of the resources that we just created with Terraform, including a load balancer. And that load balancer has a domain name here. It's the same domain name you can see over here in GitHub. And I'm going to create 2 new records, and they're going to line up with the records that we set in the CNDI init step, where we had said that we wanted Argo cd.cndi.link to link to Argo. We'll create that record. We'll create another record. Same idea, airflow.cndi.link, and set the domain name there as well. Oh, I need to be using a CNAME. There we are. So those 2 DNS changes might need to propagate, but we can go to the domain and hang out here. Pretty soon the TLS certificate should be fetched from Let's Encrypt, and we'll be able to log into Argo CD. Here we are. The Argo ingress has been deployed successfully. Argo cd.cndi.link now points to that load balancer, so traffic is getting routed correctly into the cluster. In order to log into Argo, we just need to go back to our .env file here and see that CNDI actually generated an Argo password for us. We'll put that in the clipboard. The username is admin, paste the password, and here now we're logged into Argo CD. We can see that the Postgres instance has already been deployed successfully, and that Airflow is currently deploying. We're filtering by progressing right now. We can see that there's a great number of services and resources that are being set up right now, and there's just 12 to go. And once these all finish spinning, we'll be able to log into Airflow. Should just take a minute. There we go. We can see that all of the Airflow resources have synced. They've all gone green. There's none progressing and none degraded. That's awesome. Now we can go to airflow.cndi.link, and we're presented with a login screen there. The passwords were admin. We can enable the hello world Python script I have here. We can see that it's running. And when it exits successfully in a couple seconds, there it is. We know that the Airflow Kubernetes executor is doing its job. So there you have it. We've deployed Airflow with a dedicated Postgres database, and there's just kind of one thing left to show you, and that's how easy it is to make changes to these clusters after they've been deployed. sometimes called day 2 ops. Whether you want to add another node to this cluster, or if you want to change anything about the configuration of Airflow or Postgres, all you need to do is to change this CNDI config file and call CNDI OW. So I'll add another node to my cluster. We'll call it YZ Airflow node. Do CNDI overwrite. We expect that to have resulted in some more Terraform files. There we go. We can see there's new AWS instance there. We git add. And we commit that we've added a new node. And we push that up. And it will just be a couple minutes before we have yet another VM in our cluster here. And of course, yeah, same applies to Kubernetes manifests. You can change anything about the cluster at any time, and it'll be synced up just seconds later. So I hope you've enjoyed the demo here. We'll continue to add more templates beyond Airflow, more databases. Definitely let us know if there are templates that you'd like to see added, and we'll be coming out with more deployment targets as well. This was EC2. We also have Azure and GCP support and support for EKS. But even more deployment targets coming down the pipe as well. We're most excited to see what you guys build with it. You can create your own templates, and this cluster, it would be just as trivial to come back to this upper section here and say that actually we want to deploy on GCP instead. And that's all it would take if we've swapped those 4 nodes. We could pack up our cluster and move it just that easily. So I hope we've shown that self-hosting really isn't hard anymore, especially with CNDI. And we're excited to see what you build with it. Thanks.